Today we will see how you do mix design by Indian standard method. As we know, for concrete grades greater than M25, we have to do mix design. For M5 to M25, there are fixed proportions like 1:1:2, 1:2, 1:2, 1.5:3. But above M25, we have to do mix design. There is no fixed proportion. So let's see what's given. Grade is M35. Characteristic compressive strength for required for 28 days is 35 MPa. MPa means Newton per mm square. Then type of exposure is moderate conditions. Target slump is 150 to 175 mm. As we know, we perform a slump test for knowing the workability of concrete. So here target slump is given 150 to 175 mm. Maximum size of coarse aggregates is equal to 20 mm. Fine aggregates is zone 3. We'll discuss about this. Specific gravity of cement is 2.93. For water is 1. For admixture is 1.1 to 1. For coarse aggregates is 2.82. For fine aggregates is 2.65. Water absorption of coarse aggregates is 0.86%. Water absorption of fine aggregate is 1.25%. So our first step for finding quantities for mixed design for M35 is target mean strength of concrete calculation. First step, F-CK is target mean strength, FCK is characteristic mean strength or grade, plus 1.65 into S. S is standard deviation. As we know, grade of concrete is 35, plus 1.65 into S. Here S is 5. How do we get it? So S value from IS 456 2000 IS code, table 8, page number 23. Here assume standard deviation. This is the table. From this we get S value. These are the grades given, and this is standard deviation S value. For our grade is M35, so S value for M35 is 5. So we put 5 here and we get 43.25 Newton per mm square target mean strength. Determination of water cement ratio. Second, it depends on exposure. As per table 5 of IS 456 2000, page 20. This is table of IS code mentioned below. This shows mild, moderate, severe, very severe, extreme conditions. And for PCC and RCC, we are calculating for RCC. As we know, type of exposure is moderate, which is given. So for moderate conditions, and we are looking for RCC, water cement ratio is 0.5. Maximum water cement ratio from table for moderate exposure is 0.5. Based on experience, adopt water cement ratio lesser is 0.5 minus 0.05 is 0.45. Adopt lesser water cement ratio always for good strength. Determination of water content. Third, from table 2 of IS 10262 2009, page 3. This is the table maximum water content per m cube for 25 to 50 mm slump. Nominal maximum size of aggregate 10, 20 and 40 mm. Maximum water content in kg 208, 186, 165 kgs. So maximum water content for 20 mm, as we know, aggregate size is 20 mm. So here for 20 mm aggregate size, maximum water content is 186 kg or liter. As we know, 1 kg of water is 1 liters of water. Maximum water content for 20 mm coarse aggregates is 186 liters. Our target slump is 150 to 175 mm. and this table is for 25 to 50 mm. So we have to make slight changes here. As per IS 10262/2009, increase 3% for every additional 25 mm slump. Here our slump is 175 mm. So for every increase in slump after 50 mm slump, we add 3%. For 50 to 75, 3, 75 to 100, 3, 100 to 125, 3, 125 to 53, 125 to 153, 150 to 175, 3. 3 plus 3 plus 3 plus 3 plus 3, it becomes 15%. Estimated water content for 175 mm slump is 186 liters water, which have got here 186 liters plus 15% increase, that is 213.9 liters. As admixture is added, the water content can be reduced by 15%, and above plasticizer admixture used, actual water content is 213.9, which we have got here, minus 15% of 213.9, we get 181.82 liters. If we add admixtures, we can decrease water content, which results in increase of strength. Fourth is calculation of cement content. As per table 5 of IS 456/2000, page 20, for moderate exposure, minimum cement is 300 kg per meter cube. Where do you get it? Here. For moderate conditions, minimum cement is 300 kg per meter cube. Water cement ratio is 0.45, as we have calculated backward. Water content is 181.82 liters, we have calculated here. Therefore cement content is water content upon water cement ratio. So we have got 181.82 liters of water, 0.45 is water cement ratio. This way we can calculate cement content, that is 404 kg per meter cube, which is greater than 300, hence okay. 300 is minimum, so we are getting 404 kg per meter cube, so it's okay. Fifth point is calculation of volume of coarse and fine aggregates. From table 3 of IS 10262/2009, page 3. This is table. Volume of coarse aggregates per unit volume of total aggregates for different zones of fine aggregates. Nominal maximum size of aggregates. These are sizes of aggregates. These are zones of fine aggregates. 4, 3, 2 and 1. So our zone is zone 3. So you have to look into zone 3, and size of aggregates is 20 mm. We get 0.64. Volume of coarse aggregates corresponding to 20 mm size aggregate and fine aggregate zone 3 is 0.64. Now actual water cement is 0.45. It is less by 0.05. 0.5 minus 0.45 is equal to 0.05. And as the water cement ratio is reduced, it is desirable to increase the coarse aggregate to reduce the fine aggregates. We have reduced water cement ratio by 0.05. So with reduction in water cement ratio, we increase coarse aggregates to reduce the fine aggregates. It is desirable. With decrease in water cement ratio, increase in coarse aggregates. The coarse aggregate is increased at the rate of 0.01 for every decrease in water cement ratio of 0.05. So we have only reduced 0.05. So corrected proportion is volume of coarse aggregate is 0.64. We have got this from this table, plus 0.01. 0.01 increase for every 0.05 decrease in water cement ratio. So we get 0.65. Since it is angular aggregate and concrete is to be pumped, the coarse aggregate can be reduced by 10%. concrete is pumped, so it can block the concrete pumps, so reduce the coarse aggregates by 10%. By reducing 10%, we get 0.65 minus 10% of 0.65 is 0.585 volume of coarse aggregates. Volume of fine aggregates is 1 minus volume of coarse aggregates, that is 0.415. Next is sixth step, design mix calculation. For volume of concrete 1 m cube, volume of cement becomes, as we know, density is equal to mass by volume. Here volume of cement is equal to mass of cement upon specific gravity into 1000. So here we have to find density, then specific gravity into 1000, formula for finding out density. As we know, we have given specific gravity for cement, water admixture, coarse aggregates and fine aggregates. Here we have to put specific gravity of cement, that is 2.93. So mass of cement is 404. We have got it here. We have calculated here 404 kg per m cube. Specific gravity of cement is 2.93 into 1000. We get 0.138 m cube of cement, volume of cement. Volume of water, same formula, mass of water, specific gravity into 1000. Mass of water we have calculated. We have calculated 181.82 liters. Volume and mass of water is same, so specific gravity is 1 into 1000. We get 0.182 m cube. Volume of admixture, mass of admixture, specific gravity into 1000. Assuming dosage of 1.2% by weight of cementitious material, 1.2% by weight of cementitious material is proportion for admixture. 1.2% into 404 is cement in kgs, kg per m cube. So 1.2% of cement divided by specific gravity into 1000. Specific gravity for admixture, as we were given, 1.121. Then by calculating it, we get 0.004 m cube. Next, E is volume of entrapped air. 2% for 20 mm coarse aggregates, 2% is 0.02 m cube. You have to calculate volume of entrapped air also. Next is F, volume of all aggregates, coarse plus fine. Volume of concrete, that is 1, volume of cement plus volume of water plus volume of admixture plus volume of entrapped air. By putting all these values, we get 0.656 m cube is volume of all aggregates, coarse plus fine. Then G, mass of coarse aggregates. Volume of all aggregates, this is formula for finding out mass of coarse aggregates. Volume of all aggregates into volume of coarse aggregates into specific gravity into 1000. We have got volume of all aggregates, that is 0.656. Volume of coarse aggregates we have find out, and then 2.82 is specific gravity into 1000. We get 1082.2 kgs. Mass of fine aggregates, H, volume of all aggregates into volume of fine aggregates into specific gravity into 1000. We get 721.4 kg is volume of mass of fine aggregates. Then proportions, this is table what we have got. Cement is 404, we have find out. Fine aggregates is 721.4 here. Water is 181.82 liters. Coarse aggregates is 1082.2 here. 60% is 20 mm aggregates and 40% is 10 mm aggregates, coarse aggregates. Admixture is 4.848 then water cement ratio is 0.45. This way we can calculate proportions for a mix of, like, for any grade above M25. This its proportions. Thank you.